Hi again, Year 4. Well, you've had 2 days of having a look at pictograms, tally charts and bar charts, and today you are going to be looking at line graphs. So I'm going to give you a little bit of an introduction to them. So what is a line graph first of all? Well, here's a line graph on your screen now, and this line graph is showing the temperature in Birmingham over 12 hours. And again, a little bit like the bar chart, you've got the scale at the side, and here it's counting up in twos. So that's important to notice. And this is the temperature that was taken. So this is the amount or how hot or cold it is going up the side. Along the bottom is the time, and the time is counting up in hours from 7 o'clock in the morning to 6 p.m. at night. And the line graph shows you what temperature or how the temperature changes over the course of those 12 hours. So it's very similar to a bar chart, but is a little bit more sophisticated and normally shows a change over time. That's where line graphs are really useful. So if we start with 7 o'clock in the morning, at 7 o'clock in the morning, if I follow my line up, if you see my cursor, I can see that at 7 o'clock in the morning, if I go to the side, the temperature at 7 o'clock in the morning was 2 degrees C. If I have a look at 8 o'clock in the morning, the temperature had risen. I can see the temperature is going up. It's getting hotter. And we would expect that, wouldn't we? It gets warmer throughout the day. So I'm following the line up from 8 o'clock and I follow it up here. And if I go across, and using a ruler sometimes is really helpful for this. I can't on my screen, but you can. I keep losing my cursor as well. So going over here, if I followed it across, that line at 8 o'clock would be halfway between the 4 and the 6, and we know that that would be 5 degrees because halfway between 4 and 6 is 5. So if you have a look at this line graph, at what stage is the temperature, or at what time, is the temperature the hottest during the day? So we're looking at the highest point in the graph. And so if I follow it up to the highest point, which is here, and follow it back down, I can see the hottest point of the day where the temperature was the highest was at 12 o'clock. And the temperature at 12 o'clock, can you tell what it is? Halfway between 12 and 14, it was 13 degrees. So that's how line graphs work. Fairly straightforward, but you need to be careful that you're looking at what the scale is going up in. I've got one of the graphs that you're going to have in your work today, and this line graph shows the growth of some cress, which is that fast growing salady stuff, over 10 days. And again, we've got a scale going up the side saying how tall did the cress grow in centimetres and what day it was. So at day 1 when it was planted, it hadn't grown, so it was 0 centimetres. The tallest point, or the day at which the cress was at its tallest, was day 8. Can you tell me how tall was the cress on day 6? So you need to go along the bottom and find day 6. You need to go up, follow up the grid lines on the graph. I've hit the line on day 6. My cursor's going all over the place, so there you go. I'm up here, and if I follow it over to the end, the height of the cress was 10 centimetres on day 6. And you can figure that out for day 4 and day 8 and day 10 if you wish. And there's questions about this line graph in your work pack today. There's also this one here, which you might go, oh my goodness, it says fill out the missing information. You go, well, how can I? I don't know anything about it. Well, you know this is the distance cycled in miles. This is 0 and this is 30. So what this question is actually asking you to do is figure out what's the scale, what do you have to count up in? So you can try. Are you counting in ones? 1, 2, 3, 4, 5, 6. No, because you don't get to 30. Are you counting in twos? 2, 4, 6, 8, 10, 12. No, you're not counting in twos. So you have to figure out what you need to count in, remembering they're equal jumps that would get you up to 30 there. The same thing along the bottom. So the time taken in hours, we know this is 0 hours and we know this is 10 hours. So is this going to be 1, 2, 3, 4? No, can't be. Is it going to be 2 hours, 4, 6, 8, 10? Yes, it is. We're counting in twos. So each distance between the lines is worth 2 hours. So don't be panicked by questions where you have to fill in the gap. You just have to look closely at the graphs and it will give you all the information. You've just got to do a little bit of working out for yourself. So enjoy the next 2 days online graphs. I like statistics. Statistics is a really nice little bit of maths. And again, you can see that in 10 hours, this cyclist had done the most amount of miles. And we would expect that, wouldn't we? That the longer you've cycled for, the more miles you have gone. But you can see, well, between which hours did he cycle the most? And which hours, perhaps here, can you see where do you think this cyclist had a rest? Where he didn't cycle anything. So he wouldn't... I'm thinking here, because he didn't travel any further. So I'm thinking perhaps he had a rest here. And I wonder what time he had his rest. Perhaps he stopped for a lemonade and a nice healthy juicy apple if you're cycling. I doubt he would have a chocolate bar like Mrs. Hartley. Right, well, good luck with your maths today, and I look forward to seeing what you've managed to do.